Let's start this amazing event. Actually, I want to say that I've did many talks, but I've never done a keynote. I'm freaked out. And this is the best audience to do the keynote to. And I always said that at CppNow, you have that feeling that the audience knows better. That's always true, right? So I'm pretty sure you know all the language things better than I do. So sorry for that in advance. But I think there is an area which I'm good at and which I'm happy to share with you here, and that's the tooling. I'm passionate about the tooling on my own and with my company, and I'm happy to work in the company where my personal goal is actually aligned with the company vision. And our vision is to bring tools for everyone who is doing development and to make them great and to implement their ideas quicker in code. So before we start, just a few things, and I can't avoid doing some very, very brief promotion. So yeah, as Bob mentioned, so I worked in C++ for about 8 or something like that years, doing just like a software developer. I was mostly working in embedded stuff, doing some low-level things, doing some C, working in Vim. I was a Vim person for 3 years. I loved that a lot. I still love all these embedded things. And I was working in telecom areas, and I was responsible for launching some 4G LTE networks. You can blame that me for that as well. I joined JetBrains when they started C++ tools, and that was 10 years ago. I have a fantastic milestone this year. But now finally, after all this year, after nearly 20 years, I'm doing C++ as a hobby for myself, because I'm no longer in charge of C-Line. I'm no longer in charge of the C++ marketing. I'm just doing that because I love that. I'm now head of marketing and biz dev in .NET tools, so you can blame me for that. But like C++ is something that stays with me. And I love C++ and I love the communities that are doing C++. So when I moved to Netherlands, I can't escape. I'm running the Dutch C++ meetup there. So if you're anytime around, you know who to ping to join our fantastic meetup. Or for sure, because we're all here quite great and we're good speakers, join us and speak. We're always open to fantastic speakers from C++ community, and we're open to any topics, so please come. And moreover, we're launching a first ever Netherlands C++ conference, which is C++ under the sea. You can try and get the joke because 75% of that country is under the sea level. So we are running in Breda in October, 11th of October. Call for paper is open. I'm the program committee chair, so you can blame me for that. And I'm trying to engage everyone here to submit, because that's a fantastic event. We have Jason Turner confirmed as an opening keynote speaker. And it's just one day, but you'll enjoy Breda. Amsterdam is close. Other fantastic cities in the Netherlands are close. It's just a quick way from Schiphol or Eindhoven, which is cheaper. So all the things are yours there. Just join us and enjoy the conference, and I think we'll have a great day there. That's it with the promotion. Now to the talk. So we're going to talk about these things. Some of them are shorter, some of them are longer, some of them I was somehow presenting through these years a little bit. Some of them will be just stories, somehow related to toolings. Don't take them too serious. But the most important point which I want to state before I start with this talk is that it's called C++ Painkillers, and I used to run my talk titles and talk descriptions through our copy editing team in JetBrains. And they told me from the beginning that it has kind of negative connotation. And I told them, yes, this is on purpose. I like tooling, I'm a tooling person, and I think we all have to find and use proper tools and build proper tools. But don't get me wrong, language comes here first. Language is more important. If we can address the problem in the language, we should do that. But if the tooling could help you build this language feature or address it until you build it, we're here from the tooling vendor perspective to help you with that. So don't rely just on tools and forget about the language evolution. That's not what I'm aiming you for here. So language is more important, but the tools are also crucial. And we're going to talk about the tools. And I'll start with a story related to tools, but completely unrelated to C++. Sorry, but I just love the story. So my kids in Amsterdam are in the international school. And I really appreciate that because they have kids from all over the world. They're celebrating all the holidays. It's just a nightmare for parents. But they have fantastic and diverse community because everyone is coming from their own cultures, their own countries, their own traditions. And they do celebrate and respect all these things. And I think that's a fantastic environment to teach your kid how to celebrate and how to respect the diverse community. And they have, because we're in the Netherlands, the main language for the education is English. They have, of course, Dutch and other languages running there, but they do celebrate the home languages for the kids because they think that the home language is the foundation for the whole educational process. And they ask parents explicitly not to switch to English at home so that the kids still can, learn the home language and be with the home language. And so once in a couple of months, they run these events, which are called home language mornings, where all the parents are invited to read or to do some activities in their home language with a group of students who do understand this language or who are interested in that, for example. Maybe that's not their home language, but they're interested in that. Like my older kid, he has a friend from Panama who is learning Russian in Duolingo for a year now. Can you imagine the dedication of the 80-year-old kid to do the Duolingo for years? I actually escaped from Duolingo much faster. So anyway, they were running this home language event, and it's not just reading, it's usually somehow special so that they do some activities. So they asked us, parents who are joining, to find out some inventor or some notable person whose achievements we want to celebrate in the home language from who was speaking our home language. And together with my older kid, we decided to select Alexander Popov. He's inventor of the radio. And if you don't know, that's him. And we talked to the kids about the invention, about the radio, about the purpose. The goal of the whole event was just to discuss the problems the guy was trying to solve and how you could address that and how it actually all happened. And it was very interesting to see how the kids immediately grasped one of the main idea. We were discussing with them the tools which people were using in the end of the 19th century for passing the information. We were discussing the signaling fires, the pigeons, and this fantastic flags approach used on the Russian fleet these days. And they immediately grasped the very key factor that is all great, but too slow to pass the important information. Imagine you're in the battle with a fleet, and you have to pass some information, and you're using this. Right? So it takes ages. It's hard to see. Everyone else also sees that. Pigeons are also nice. They can fly through huge, long distance, but what happened to the pigeon if something goes wrong? Maybe there are some other animals, whatever. And the signaling fires, they're just super slow. And the kids were surprised that you can at least pass any message with that approach. So they grasped the idea quite quickly, and we discussed the radio and how the radio signal was passed and this fantastic tool. And they were quite happy to hear that it was actually used soon after the invention. So it was exactly end of the 19th century, and in the year 1900, this device already saved people, some fishermen on the ice, and it's also rescued some coastal defense battleship which ran aground. So they were surprised how the people actually managed to invent the actual tool and actually do the real job with that so quickly. And so our whole discussion was dedicated to tools. Surprisingly, I can't escape that, even in my kids' school, right? Talking about the tools. So the tools, they do help us, right? And they're really important. And when we talk about the language, so why this talk? Why we actually talk about tools? Do we have any problems or why? So let's discuss if we have a problem. So every year, the C++ Foundation runs a fantastic survey where they do ask about which of these do you find frustrating about the C++ development. And I have to say that this table comes from this recent survey, 2024. The results were just released maybe a couple of weeks ago in the beginning of April. So this survey ran, I guess it was in March. Funny enough, I was updating this table from year 2023, and I haven't updated a lot. I just changed some numbers, some actual percentage, but I really didn't even reshuffle the points here. So everything just stayed as it was. So there was a very quick update. It took me like maybe 1 minute to just update the numbers to show you the correct percentage from the actual survey. So the frustration points for years stay the same. And I used some color code here. So the yellow ones, which are mostly on top, are directly related to tooling ecosystem. Green ones are more related to language, but we'll see today how we also can help with the tools. And the pink one are just others, but they also have some relationship with tooling, especially the debugger one. But I just need some color code to be straightforward, so I use that. And the point is that if you look at the table, even if you're in the back row, you can see that the yellows is like half of the table, the upper half is in yellow. So we all are frustrated about the tools. Why this? Why this actually happens? Tools are on top of this page for years now. And I have to say that we're doing a better job with the tools than like 10 years ago, but they're still here. So let's dive deeper. Actually, this talk was inspired by a couple of things. So I heard for the first time about this idea when we were looking at this table together with Timo Dumler while he was working as our developer advocate in C-Line team. And we decided to write a small blog post like how to address 7 major C++ pain points with C-Line. We were just trying to look at this table and suggest a solution from our tool to the pain point. And there is a link to the blog post we published in the end. And then there were 2 talks by Victor, the Mythbusters talk. I think if you've heard of it, these are great talks. I really recommend you listening to that. At an NDC Tech Town last year, I listened to this version 2 in person. That was fantastic. I really loved that. And the whole idea was that, like Victor was revealing the myths about the C++ and then showing the tools that could help you address the myth. And I was really impressed. It's a great talk. I do really recommend you watching like both editions. But that made me think like, okay, so we have the problem. We are all worried about the tools. So what are the tools? And I took this kind of framework used in the product management and other areas. And I called it Vitamin, Painkillers, and Cure. I a little bit rephrased it because originally it's like vitamins, painkillers, and candy. And this framework, it's first revealed by the Kevin Fong, venture capitalist. He's the first person to blame for this quote, like we throw away the candy, we took at vitamins, we look at vitamins, and we really like painkillers. And the idea, which then was transformed to the product frameworks, to the product marketing frameworks, and because I'm involved in the marketing, I love reading about these frameworks just to learn how the people do things. So they have this idea that you can actually take all the features you do in the products into 3 groups. There are vitamins, which are nice to have. So these like extra benefits and features to enhance the product values, but they're not essential. Painkillers, these are the must-haves. So like it solves the key problems or the pain points and you must have them in your product. And also the candies, it's like pleasure or some fun things to have, like delightful and appealing features to create emotional connection with your product. I love the framework, but I wanted to transform it to our reality a little bit. So I kind of changed the focus and also changed the candy to a cure. And I look at this way. So painkiller is a quick fix or a tool you can use to address the problem or some difficulty you have with the language. The vitamin, on the other side, is a guideline, is a code style, is some best practices which kind of helps you avoid the problem from the very beginning. And the cure is actually the solution, which quite often is a language feature, but not always. So, as I said, copy editors, they didn't like my painkillers naming, and they said it has this negative connotation. But it's actually true, because I prefer us to have the cure and the vitamins, and the painkillers be only the absolute necessary set, and the tools can help. But if you can help with the language, it's better to help with the language. If you can help with the guidelines, it's better to help with the guidelines. So vitamins are there to prevent, and like the cure is the best case. But painkillers, they kind of help instantly, immediately, right? So you just get one and you can go and continue with your job. So that's what we need sometimes. Just go and continue with our job, whatever the language has, whatever the guidelines we have around us. We just need a solution. We just need a tool. So, and that's why I do call the tooling painkillers here. So let's talk a little bit about when and where the tools can help. And I will be using several examples, not the full coverage about when and where the tools can help, but just to illustrate some examples which I feel are relevant and which I also experienced. So because I was working with embedded development for that very long, I was like hugely using macros. I couldn't escape them. In embedded, everything is in macros, right? Every vendor of the hardware, they do provide you quite a long description with all these macros, how to work with things. And I learned that the macros could be quite hard. They could be nested. They could be spread around your whole code base. And that's just a textual substitution. So sometimes you have to deal with them and you have to understand what this actual macro in this point of your code actually means. And that's the essential thing you want to understand about this piece of code, especially when you're looking at the new code base. So sometimes you can just, navigate through your code to the macro definition and look at that. Sometimes the tools could do better and then can do some like substitution of the one step or even the full macro substitution. And sometimes, they can just show you without substituting in the actual code, they can just show you what is actually behind this macro. So sometimes you can just ask your tool to show you the full replacement for the macro with all the nested macros, and you can literally see what's there, what's behind these calls. So I can see that the first line actually goes to this class A with everything in there, and the second line goes to everything with class C with everything in there, and everything is substituted, and I don't need to spoil my code base. Or maybe it's not my code base, but the code base of my colleagues, or the library code base. I just look at that. And I have to say that when I first was showing this feature to, I guess it was CppNow, it was Louis Dion, when we talked to him, and he was working with Busana a lot, and I just show him how you can open and see the whole macro replacement formatted and highlighted properly. And I saw that enlightenment moment in his face, literally. He was like, wow, I can do that. I don't need to run all this stuff. I don't need to see how the preprocessor processes all my stuff. I can just press this and see the code documentation showing all this replacement to me. I literally saw how enlightened his face was, and he was so happy about that. I never saw that again, I think, like making the one person happy with just one feature. Usually it takes about 2 or 3 to make the person happy, but that was just with one feature. Because sometimes this stuff with macros is really hard. These macros are simple, actually, so I don't really need this. I can guess it easily. But with Boost, it's much more complex. And sometimes we say, like, okay, we can substitute the macros in our code. And I've run once at this example when I had something like that. So the macro which does some enumeration inside. And if you substitute the macro here, you break the things. Because if, say, I substitute the line in the middle, the second UVAR call, I have things broken. But when I just look at that in the, say, quick documentation, I can see that, this is the var 0 and this is the second var, and I can see actually what's behind these macros. And I'm not breaking anything. I'm just looking at my code and I'm grasping the idea behind these lines of code easily and quickly. Macros are also quite often used for unit testing framework. And every time I look at the boost macros or cache macros, I'm like, every time I'm like, what's behind them? And every time I open this, I'm just scared to death. But it's good to see that it's actually properly formatted and highlighted. At least I can get some ideas. Sometimes I can even figure out how my test will be named properly, so to understand what the compiler output is trying to tell me. This kind of things kind of help me a lot with macros. And also, like, if we talk about the boost, there is this fantastic boost PP repeat, which I really love, but it does lots of stuff behind the scene. And sometimes it actually substitutes the whole bunch of, like, definitions to me. So yeah, when you have a tool which can quickly show you what's behind your code, it's really helpful. So you can get these enlightenment moments, you can understand the code base better, and you can actually understand the maybe the compiler output better or what's happening in your code. Another example, if we take the C++, is when we talk about the overloads. C++ is unique because we can overload operators, which is great. It's a fantastic and powerful opportunity. But now let's see what's happening here. So I have this class fraction, and I have this fantastic stream output operator I'm using to output the fraction. So it's here. And then I have this output string in the very end, and there are several stream output operators called in there. I remember when I was first showed this example, that was Tony Van Aert in the first row, and I made one mistake because I told to the audience that I have these overloaded operators, and he told me, no, they're all overloaded, yes, for sure. How many of different overloaded stream operators are here? Let's count. So I have this fraction class overload for this stream output operator. So actually I call 3 of them here because the multiplication of the fraction is also a fraction in my class. Then I have the overload for outputting the string and also the last symbol, the character. So there are 3 different operators. But if you look at the string, they look all the same, right? So they're just one symbol. And when you look at this kind of code, every time you have the operator overload, the biggest issue is that you're trying to think and grasp what is actually behind this operator, what it's actually doing. And sometimes it's quite straightforward, sometimes it's not, sometimes you just have some variable and you have to remember, so what is the type of the variable? Do I have this operator overloaded? How does it work? So what it's actually doing? But the tools, they usually like, especially if we talk about the tools working with the language, they build the full AST. They have a clear answer to you because they know that this operator was overloaded. And you can see at the screenshots that the tool is actually highlighting me the similar operators when I have the caret on the first operator for the fraction. The other 2 are also highlighted to me because the tool knows they're the same. I can define usages for this operator. I can navigate to the declaration of this operator. I could immediately learn what this operator is actually doing. And I can do that for every stream operator or learn more. So kind of the tools, especially those that are working with the AST, they're quite powerful because they already know all your code for you. You don't have to dive deep with every line of code because you just ask the tool and it helps. Another thing is about the name parameters. I'm not going to dive into the whole discussion about the name parameters in the C++ here. And I think there are people in this room who know these proposals and these discussions much better than I do. However, I was really impressed when the first proposals appeared because that's such a straightforward idea to have the name parameters in the language, and we don't have them. We're like, yeah, we just enumerating our parameters, the first one, the second one, the third one, and we just work with them, and hopefully I pass them in the right order. Otherwise, if they're at the same time, I just messed up with my code and the compiler doesn't catch that. Then we start inventing the approaches, like saying, okay, so maybe these 2 types doesn't mean the same thing. Let's wrap them with the proper type, which is a good approach. That's a great guideline. Sometimes you have to wrap with the proper type, not just relying on a straightforward integer, right? But sometimes it's just an integer. Sometimes an integer doesn't have to be wrapped with anything else. You just pass in, say, a couple of integers in a row, and you just don't want to mess up with them. And I saw a fantastic paper once in the past from, I guess it was from Google, where they created this approach. So if you name your parameters properly, the heuristics they built, and say, for example, then you can implement that in the static analysis, could detect the cases when, for example, you swap the parameters. So if you're lucky enough to name your height and width parameters properly in your code base, then the code analysis tool will be able to tell you that probably you missed the order, so probably they're in the wrong order right now. But that's only if you manage to name them properly, and we're all bad at naming, I guess. So, like me for sure. So, but the name parameters, they definitely increase the readability and they reduces the level of mistakes which are happening because of these swapped orders. And also, that actually happens often because the declarations are all the time far away from the users, right? So they're all the time somewhere. But also the name parameters are kind of helping us with these default values, because if I want to do several combinations with several default values, sometimes some of them are not possible. And as one person noticed to me, and I really love this quote, is that overloads work like a charm when it works. And they were, the first proposal was this N4172, which was declined, then was the second one, and there's this fantastic boost parameter by David Abrahams and Daniel Wallin, and I really love this library. And there was this talk by Richard Powell, and I was really impressed by this talk at CppCon 2018 about the name arguments from scratch. There's a whole session of the live coding and doing some library with metaprogramming and handling your name parameters. It is fantastic, it is inspiring, but I just want to name in parameters. Can I get them without all this meta-programming stuff? Okay, actually I can, with a good tooling. So this is a very simple thing the tool can do for me, because the tooling which works with the AST trees of the languages, they know all these parameters. They know how they are named. So they can just show you a quick hint. Just in the code, just in gray, like here, I can see what is the position, what is the X position, what is the Y position, what is the speed, what is the width, what is the height. And if I miss the mark, I will see the hint and I will probably think, no, I'm not entering the height here, I'm entering the width here. I'm wrong, I should fix it. I know that some people do have mixed feelings about these parameter hints, because sometimes they are really freaked out when you start typing in your code editor and then the line extends magically. And there are some things entered in this line that are like, no, just don't do that to me, how to turn this off. Some of these people are converted to the parameter hints lovers after like maybe half of the hour using them, especially when they have lots of calls with the similar parameters or the similar type. And sometimes the tools actually, because the tools are for you, the tools are for the users, so they learn how to adopt. You can turn this on, you can turn this off. In the tools, we do implement the things like push to hint. That's the thing we implemented in our Sharper C++ tooling when the users asked us. So when you actually say, okay, I don't need the hints, but sometimes I want to see them. Can I just press the shortcut? They will appear while I'm like getting this shortcut. When I release, they disappear and I just proceed. We say, yeah, okay, why not? That's easy. So the tools, they can adapt to the way you work with the code. So they can show you these hints, or they can, and you can actually quite often configure in what point of code you want to see the parameter. So you definitely probably don't want to see the parameter hint when it's just one parameter in the function. Who cares, it's just one anyway. So this is all configurable because the tools are adjustable. And you can do with them, configure them the way you work with the code. The thing about the passing the parameters, which I find very useful, is that sometimes the parameter hint can help you and hint about if it's passed by value or passed by reference. Because they know when it's passed by reference, and they can simply show it. Look, there is this reference sign before the ball call, ball parameter. So the tool knows that that's passed by reference, and it can show it to me. So I'm like, yeah, that's good, I know, I'm passing by reference. When we invented these parameter hints, we started thinking further how we can help the developers of different languages with this kind of hints in the editor. And we learned that we can help with the type hints. And you know, like when I was doing the C language, or maybe like 15 years ago when I was doing C++, I never felt the necessity for the type hints. But now if you look at the top part of my example, I have this do operation call, which deduces the type, and then I have several calls for the do operation with different arguments. So I call with 3 and 0, and I guess the op variable of the type int. I call with 3L0, I get the op1 of the type long, and then I call with 3.0 and 0, and I get the type double. And there is no information about these types anywhere in my code base. But I have this because I have the type hints. Because the tool actually that knows the AST can immediately deduce the type for me and shows it to me. And I have it. And it's useful for the cases of these like deduced return types. It's quite useful with lambdas. And I find personally it's super useful for the structured bindings. When, say, I'm assigning the tuple, and I just want to understand that I'm doing the things right here and right now. And I'm assigning the tuple, and the tool actually shows me which types I get in the end. And I can double check that I'm like writing it properly. This is about the types. Which other things the tool can help us with? Actually, every time, except you work with some general libraries, most of the times we work with some domains. And in every domain, there is a domain-specific language. And it could be just that we understand that there is some domain-specific language, or it could be literally coded in some or another way. If you're aware of the Unreal Engine, which is one of the most popular engines for game developers, especially for all these AAA, big C++-based games, these people still wait for us to deliver reflection in C++. So for years, they struggle with that. So Unreal Engine has the whole reflection mechanism implemented with macros. And these macros inside, they have line and file macros, which is even worse. And like 5 or 7 years ago, I saw how the code editors are just blown away completely when you start typing the code before you say uClass declaration, because the line changes until you compile, you have everything like in red squiggles. Later, the tools learned how to deal with that, so we don't rely on the parsing of the actual C++. We do parse your DSL here. We do parse these Unreal macros. We know that what they mean. And moreover, because this reflection mechanism, you run these classes and you have these properties and functions with this uProperty and uFunction macros, and you have some reflection specifiers to pass to these macros. And usually, if you just take the regular macro, it's just the text. But for Unreal Engine developers, these are never text. That means a lot. That means like how to serialize it. Is it blueprint callable? There's tons of information behind every single line of this text, of this macro. And if you parse that properly, if you teach your tool to do that properly, then the tool knows that that's not the text. That's actually a symbol. That's a reference. We can autocomplete that. We can show you this fantastic documentation explaining what this specifier actually means or what this macro actually means. And every time the tool does that for me, and I think every time the game developer newly converted to these tools see that, and now you have this in our tools, you have it in Visual Studio, Visual Assist does that the same for Unreal Engine, they're all very much impressed because that makes working with this macro much easier. And these people, they are struggling with these quite hard gaming code. They don't want to struggle with our macro. They want when we deliver the reflection, I think they will celebrate for a year or two. And hopefully they will forget about these macros. But until we're there, they have to use this macro approach. And I have to say that that's the most powerful feature of the tooling, that the tooling can actually treat any sequence of the symbols, which is just text, as symbol. And every time the tooling that works with the language can treat something as a symbol, you immediately get the whole universe for you, because you get autocompletion, code documentation, find usages, rename, whatever. Everything is yours when you treat something as a symbol in a language tool. Talking about the other areas where the tools can help is specifically when you are trying to enforce the guidelines. And I think we all realized that after the CPP core guidelines were introduced. Bjarne talked about that many times, that please do deliver the tools that do force the CPP core guidelines on people, because people don't want to follow the guideline just because you ask them. No one wants to. They have their other important types of tasks to do. not to follow the guidelines quite often. But unfortunately, they have to, or we want them to. And the tool can help. The tool can help with the adoption of the guidelines, and the tool can help with the enforcing the guidelines. And it becomes crucial for every adoption. So be it CPP core guidelines, or be it a fantastic like modernized checks from the Clang tidy, where you can actually not only detect that some code could be transformed to a more than C++, but also this last column actually shows when the quick fix is available. And you see the whole column except for one with yes in the Clang tidy, the recent version. So yeah, it's not all the cases where you can modernize the tool, but you can automate quite many of these things already with the tool. So you just go to your code base, you run the whole Clang tidy on that, and it shows you like, yeah, you can modernize this, you can convert this for loop, you can do this, and then you apply all these quick fixes, and you're done. Just you can go and drink your coffee, you have all your code base now in the modern C++, or at least close to it. So, and it actually helps with onboarding the new members to your team, because it makes it 100 times faster to adopt a new member when you don't have to explain all the guidelines, but you just tell them, just follow this tool, it will guide you. You will learn all the guidelines, you can come to me and ask the questions why so, but just follow this tool, just listen to this advice, and that's it. And interestingly enough, we also do run in JetBrains the developer ecosystem research. You probably have heard about that. I personally talk a lot about it because I really love it. And we do collect the information about all the languages and all the ecosystems, including C++ for sure. And we do ask for many years which tools you're using to enforce the guidelines. And quite interestingly, for many years in a row, there are two answers which dominate. One is here and one is hidden below. The one which is here is the tool provided by my IDE, and the one is hidden is none. So like approximately 30% usually select that they just rely on the tools provided by their IDEs, and the 30% say none. And I guess none because they don't have a proper tool which will be enforcing that on them, like the proper IDE. There are other good tools in between. There is the whole family of the Clang tools, which is fantastic. And it's interesting to see the demand for that. That's interesting to see how the people do actually want to use the tools for enforcing the guidelines. Being the tooling vendor, we noticed several years ago that the people started asking us for bringing MISRA checks to the IDE. And that's very interesting stuff. That mostly came from the automotive area and companies working in this area, because you probably know that to run a self-driving cars on the common roads, you have to pass some certification, which includes the MISRA certification quite often. And in the past, they were working like they were writing the code and they were trying to pass the certification. They did several rounds. In the end, they were like succeeded, and then they can launch their fantastic car on the common roads. But they realized that the cost of this loop of fixing the thing when you run it on their certification stage is quite long, and it's expensive, and it costs money. So it's much faster when you can just write the code which is enforced by these guidelines. And so they started coming and asking the tool vendors which do the tools like the code analyzers and the IDEs also, like, can you bring it earlier to us? Can you bring it to the stage when we write the code so that we follow the guidelines, we can configure the profiles to the most critical guidelines we want to follow, we won't configure everything, and then we'll pass the certification easier. And we saw the trend, we actually delivered the tools, and I think they were successfully used, and I think that's a good trend for us. So the whole area, the whole market actually realized that they can save money with just getting the right tools. So also we see a huge demand for running the code analysis on CI together with running it locally. That's actually a good trend and a funny one, I would say, because when 10 years ago I asked at my C++ meetup user group, we were discussing the code analysis tools. I asked the people, how would you like the code analysis checks to be delivered to you? And someone told me, like, I want them to run during the weekend on the CI and deliver the result to me as a report on Monday. And I was like, what are you going to do with that? I mean, you forgot already, because you had a great weekend, right, about everything you wrote there. So why do you need this report? Just throw it away and just proceed. And we started realizing as a community that the earlier we have the checks, the cheaper it will be. And in the current world, with all the recession stuff and the people who are trying to save money, especially like the management stuff, they realize that sometimes buying a not that very expensive tool that will do the job earlier for them will save them from like wasting more money in the end. But at the same time, they want to do the health check for the project. So they do run these tools on the CI to see how the things are going there. And this is right now a very good trend for the open source projects, I would say. So more and more open source projects, which are like quite big and they have lots of contributors, start setting up something on CI to do this kind of the health checks, because when the whole world is delivering the pull requests to you, you want to know if they're doing the job right. And you do the reviews for sure, if you manage them. But sometimes you just want to do the health check. You just want to see how the project is doing there. And yeah, so we literally see the demand for the CI for this survey, and that's what Bryce highlighted with his comment to our results last year actually, it's 2023. Talking about the tools, another story. It's more related to C++ and how I worked in the past. So I told you that I was a Vim person for a long while when working with embedded, because quite often with embedded, you just have a command line and some embedded Linux somewhere. You don't have, you can't afford the proper IDE. You just have Vim or VI if you're lucky enough, and you just connect to that port somewhere and do the stuff. But then I changed the job, I changed the team, and we got this great project. We were implementing the policy controller for the LTE networks. And we had a bunch of libraries, client libraries, server libraries, and some other libraries. And we ported everything to CMake. It took us several months of pain, but we were super happy we did that. So we had several components, and as from the constructor, you can build the proper part of the project you're working with. Either you're doing, say, for example, performance testing with several components, or you're writing several different clients, or you're doing several server stuff. And it was a pain because when you try to configure this constructor and take the proper libraries, and then you build the whole project, because we had lots of code generation there and all the stuff, the whole cycle of building the whole project took about 10 to 15 minutes. So when I was coming to my workplace and I wanted to work with some piece of the project, I'm trying to extract these different components, then I tried to build it, getting several cups of coffees in between. And then my team lead, our technical lead, he actually suggested a very nice shim. He told us, like, you don't need to build the whole project. Let's do the stuff. Like, let's just do the CMake, which configures the project, and don't do the CMake -- build, which actually builds the project. And moreover, he ported these things in some nice way to NetBeans, which means NetBeans, when opening the CMake project, actually runs this configuration step for CMake. So every morning after this change, when I was coming to work, I simply selected the parts of my code base I want to work with, and I opened them in NetBeans. I quickly ran to the kitchen, grabbed my cup of coffee, came back, and I already had a whole project configured properly in my IDE. I can start working. I know for sure that all the dependencies are correct because NetBeans managed to extract them correctly. I haven't built the project, but I don't need this to start my work. I can just start work in a couple of minutes. Sometimes when the queue to the coffee machine was long, I was coming too late. But I mean, that was a great story for me because it showed me that I can use tool in some way you're not expecting maybe it to be used. But you get this flow when you just work with the code optimized in several spots. Let's be back to the C++ and the C++ toolability. And this is an important topic about how C++ is toolable. And I started talking about it in 2017. At that time, there was one of my first talks at CppCon on CppNow. And I was pretty sure that everyone knows what I'm talking there about, and they quite understand what I was talking about, because we were working with the tools for several years already. And as our C-Line team lead once told us, I never thought that I would learn the language to that extent while working on the language tool. Because what happens when you work on an IDE, you see all kinds of C++ code written by any kind of the user. If there is anything you can implement in C++, you'll see it if you do an IDE. If you want to learn language to that extent, try entering any kind of the Visual Studio or JetBrains teams for doing the IDEs. I once read this quote, I guess it was in the Titus book about the engineering at Google, and it was about the APIs, that if there is an API, it will be used by someone. The same for the language. If there is a thing you can do in the language, someone will use that. And as an IDE, we have to work with all the kinds of the legacy code. All the DKs of the language package is there for us to work with. We have to work with the modern standards, we have to work with the drafts, we have to work with the TS, because the people start using them as soon as they get them. They want to get their hands on that. They kind of have the legacy code and also the modern code, and they coexist in the same project, for example, somehow. And they also work with the incorrect code. The code is non-compilable, but the IDE has to work with this code as well. So we've seen all the types of different C++ code you could ever imagine when working with the tool. So our understanding by the time was that really we do see many issues with the language features, and sometimes they're quite hardly toolable. Everything is possible, but sometimes it takes the time. And when we're implementing the IDE, you're always balancing between the balance and the feature set, because no user will wait for 30 seconds for the code completion, right? They will just proceed, they don't need it. So we realized that we know a lot about how the language is toolable. And we started talking about that. And I remember how the people from the C++ committee and Herb was coming to me and saying like, that was enlightening. So that was like really insightful. I never heard of the language in that way. And I was like, okay, probably that's not obvious to everyone. Let's talk more about that. And we did. And I was showing various examples there. I really loved that one. I showed it, I guess, in 3 or 4 talks in a row for many years. If you've been to my talks, you know that example. And you know that all the things this code does, it actually returns 42. That's it. That's all that it does. And that's all about the C++ for me, because we have 10 ways of doing one things. And all these ways are great. Don't get me wrong. And we need one or another way in different situations, but they're all different. And there is this very popular set of features which the people are usually demanding from the IDE, like finding duplicates in the code. And we've implemented finding duplicates for Java and Kotlin and many other languages. We decided not to do for C++. And we found several open source projects which do find for duplicates in C++ code, but mostly they find the like similar examples of code with just variable name substitution of very, very basic changes. Because when you have this level of variety of how you can do the things, and I really love in that sense this nice picture, I don't remember how they were called, like Willy, Dilly, and Billy. Like, they are just nearly the same for me, but they're not, right? So we use on purpose one of these ways. And recently at ACCU, Inbal was delivering the fantastic keynotes about the reflection and the state of the reflection in C++ and what we're aiming for. And it just found out that I will probably learn another way to do the returning of the 42 quite soon. But the thing here is that indeed the sameness in C++ is quite a complex task, because we have many things which we can do differently. And some of them are just part of the guidelines, how we do the things. They are reasons to use these things. And I'm not even talking about the West cons and East cons here. I'm not going to ask you for which you're aiming for. That's the Phil's topic. But there are many other things, like almost always outer is a very, very, like, sometimes questionable, sometimes hotly discussable topic, how to use that and when you have to use that. const, trailing return types, and this virtual, and I even found it quite funny that the virtual, it's recommended to use it explicitly in Unreal Engine guidelines, and it's completely different in C++ core guidelines, which recommend the override final and no virtual at all. So there are different guidelines recommending different things. And in ReSharper C++, we even tried to build the settings to configure the syntax styles for C++, and that's not the whole table. You can do that if you really want to configure the syntax style. You can go to your tool and configure how you want it. And then use that, and then like maybe commit it to the repository and enforce it on your team. You can do that. But the idea here is that you can do the same code that produces the same outcome differently in C++. But what does it mean for the tool? Why there is any complexity because of that? I will show you a few examples which I played as a game in that old talks of me at CppCon. For example, like that. So you see this nice example. There are two lines defining, declaring like K and L. And one is the template, and another is the binary expression. So the first one, that's a template. The second one is a binary expression. And then our users come to us and say, we want spaces around less or greater than. So we want spaces in the expressions. We say like, yeah, okay, and now we need to figure out if we need spaces in these lines. Because in templates, most of the time you don't want spaces, right? Another example, which is not the same, so it looks kind of different, but I like that because I have X working differently in this example, in different positions. So the one is the constructor with parameter X, and the other one is the variable Z with type X. And so I have the same type X in both lines in different positions, and the fact is that depending on the case, sometimes I want a different highlighting for this X. Because there are guidelines when you, for example, highlight these things differently, and also the different formatting could also be the case. Another one which I also quite like because it looks very, very, very similar to me, but it's a little bit, I would call it a little bit of bad style. Because the first one is the cast of the -5 to type X, and the second one is actually the expression. And the spaces could be different in both cases, and sometimes the tool has to put the spaces for you because you want it to indent the code properly, so it has to understand if it's one or another. And finally, my favorite one, and I could put more letters until I run out of the alphabet here, but the fact is that the first one is the list of declarations, and the second one is the list of expressions. How do I know that? I see this new int in the very end, and that's what defines to me that this is the list of expressions. So this is interesting. That means that the infinite look ahead might be needed to resolve this ambiguities. So the parse tree actually depends on the very last element of this list. So the tool has to read it to the very end to understand that that's the list of expressions. And yeah, I know that's bad code. But as I said, we're working with a code that everyone could write, and this code is correct code. Maybe not the best one, but it's a correct code. So what I was trying to explain in 2017 is that to parse C++, you need to distinguish types from non-types, and that's the hardest task. Because you actually, to understand of what is on that side of the mirror, you have to track the full path and come back. And that's how you learn what is actually behind this code. So sometimes you really need to resolve the whole code to put the proper spaces. And that's probably the reason why the Clang format is not doing that. And I hope you know that. Who here knows that Clang format has the fuzzy parser, not doing the full-featured parser? That's good. It's possible, and the Clang format proves that you can do the job with the fuzzy parser without doing a proper code result because it takes ages. So no one will be working with the Clang format and adapting it to that level of the adoption it has if it does the whole parsing thing like the Clang. Even though it's Clang format, so you can't expect to do the proper parsing, but it doesn't, and it doesn't do that for the reason because it understands, like the developers contributing to Clang format, they do understand that they can't afford this full parsing. And it works great. There are some misunderstandings sometimes from this tool. Like I was playing with this code in my, at CppCon, I was doing the Lite talk about the Clang format. And I actually created this fantastic example how to kind of misguide Clang format. Because when I'm formatting with the Clang format, it thinks that A is a template, while I'll explicitly said that A is an integer. So, but Clang format, it scans from my code, finds the template definition there, and it says like, yeah, A is probably a template, so I'll format it as a template. And the AST-based formatter, it actually knows that it's not a template. It sees this A10, which kind of overloads this template. So sometimes the Clang format can be misguided, but that's the artificial example. So you still can deal with that. There are many ways how to configure Clang format to do the stuff. But yeah, so generally the AST-based parsing is more accurate. Well, it takes time because that's the full code resolve. And this is very specific to C++. Every time we're in JetBrains, the people are coming to us and saying like, we have this fancy feature, let's implement it for C++. We did it already for Java, Kotlin, Python, and Ruby. We're like, okay, welcome to C++. And then we spent like a whole hour meeting discussing why it will take us time and resources to do that, why we don't want to do that, and maybe we can figure out some different approach. Now they know that C++ is different. Everyone in JetBrains knows that. They're like, oh, the C++ team, they are different. We can do great stuff, but sometimes we're having hard times in the IDE because the full parsing takes time. And the full parsing, actually, it depends on many things. So it depends on the order of the definitions, on the default arguments, on the overload resolutions. And also it depends on the project model context. And this is the thing even more surprising to the people coming to us usually in C++ tooling, because we usually used to show them this example. So this auto KX line, actually, again, it's either a template or I just have a Boolean there. And what defines that? Actually my magic, this parameter I have there in the branch. So if magic is defined, I have one case, and if magic is not defined, I have another case. And where this magic comes from? Quite often it comes from the project model. Hooray! So if even not enough to just read through the code, you have to read through the arguments you're passing to the compiler or to your project model. Okay, let's deal with the project model. That's the tough stuff. I remember Bryce saying at CppNow 2021 in his talk that if you want a standard C++ build system, we got one. It's CMake. And it's really kind of so if you look at the data. So this is the Developer Ecosystem Research 2023 and C++ Foundation Research 2024, showing which project models people like developers, C++ developers are using. So it's not a wishful thinking that CMake is the leader. It's true, and thank you for Kitware for creating this amazing tool. But there are also others. And sometimes to deal with the project, you need to deal with the project model. And so I think that's the second thing which in JetBrains, the other teams used to joke at C++ team, because every time we start discussing something, we end up with the project model. Like, do you have a project model for us to get this information out of it and then to parse code correctly and then to deliver the language features? And they're like, oh, it's better not to start with them. We will be back to CMake a little bit later. Let's go to this part about how the tools can actually address the specific pain points. And we'll be back to this table, and I'll try to show you a few examples how these specific points could be addressed with existing tooling, because they can. The first thing will be about managing the libraries. It's on top. And I guess it's on top because the adoption for VC package and Conan are still quite low. You see that Foundation shows better numbers, but let's be honest, audience for C++ Foundation is 10 plus or 20 plus years advanced in C++ and programming, we know we need a project like the dependency management tool for C++. Those who start with the language, and we have more average audience in the developer ecosystem, so the majority of our respondents are 1 to 2 years in or 2 to 3 years in C++ development. They haven't yet tried that. They haven't yet relied on that. They're still doing it as a part of their build or compiling the libraries separately. So, but again, as with this magic constant, when we talk about managing the dependencies, managing the libraries, we quickly come to the question about the project model again. So, because to manage the dependencies, where do we manage that? How we enable our libraries in the project depends on which project model we have. And actually, a funny fact, we have a tool in JetBrains, because you kind of got the idea, we like the tools which are scanning the community. We have the tool which is scanning the GitHub. And I just queried this tool to learn what is the percentage of the repositories written in C and C++ updated after 1st of January 2020, so to be more of the recent ones, with 10 plus stars. How many of them do have the CMake list txt file? 40%, not bad. So quite many, I would say, but the other 60, they're probably doing something different. Mason, sconce, Gradle, makefiles, whatever you select. So every time you build a dependency management tool, your first question will be, okay, I'll do the CMake as the first thing. That's probably already decided. But what's next? How would I adopt these libraries to the projects which are in all the others, like project models? That's a good question. The second pain point was about the build times. And for build times, there are actually quite a few tools right now how you can explore what actually takes the time. These are the screenshots from Visual Studio, and they have these several nice features delivered in Visual Studio 2022, I guess. So these are the build insights, the tool that provides insights to the include files and include tree, and you can actually view and analyze and optimize the include files. Based on that, you can actually see how many seconds were spent on each part of your project and optimize based on that. And there is also the include cleanup, which cleans up the things for you. It either like removes unused headers, or it adding transitively used headers, or doing like both things. And also there is an include diagnostics. Yeah, so I hope the animation will run. So you just call this include diagnostics, and it shows you some interesting information as a hint in your file, like how many references you have and how much it took to build these things. And then you can work and optimize based on that information. This is a nice tool, actually, that could help us improve our include stuff. So it's still not one button. It's not a magic button like get me the better build times instantly. It still takes some time, and it requires some job from you to be done. But you actually have the tools to analyze and to see the data, and then it's you who are acting on this data. And also I find it very interesting that you can profile the CMake steps. Do you know that? So because the CMake actually supports this profiling format, profiling command, you can pass the proper arguments, and you can output the argument in, say, Google Trace format, which means you will be able to open in any tool which supports the Google Trace. That's kind of standard format for the profiling, and you will be able to see the flame charts. That's not profiling the actual build of your code, that's profiling the CMake configuration step, but it's also quite insightful if you want to optimize both, how much time you spend, say, on your CMake configuration, then how much time you spend on the actual build, that's another thing. So, and you can get these things. The CI pipelines, I don't think that's very much specific to C++, but I just wanted to say that there are quite many things possible right now with the, we have some, we have test frameworks, we have support for them in various tools, and we have different CI integrations and variety of tools supported there. And there are also different visual tools which can help you visualize the pipeline. But again, it's not specific to C++ really, it's kind of a general thing. But again, there are tools to help with that. I want to focus more on CMake, and I really love this talk from Mateusz. Again, it was the CppNow, the virtual one. He had a quiz in this talk in 2021. It was CMake plus Conan 3 years later. I failed. Personally, I was trying to answer, but I think I failed at least half of the questions or even more. Because CMake is a great language for quizzes, do that if you want to run a quiz in your company. But the good thing is that we do realize that CMake is with us and it's one of the most used and the main project model. So we started building tools for that. And we started treating CMake as a language. It also improves as a language. It's now like the proper CMake. It's now more focused on these target-oriented approaches. It's more focused on what you actually want to achieve. And the tools started building the support for CMake as a language, because it actually is a language. It's not just a project model, it's a language. Maybe not the easiest one, maybe this is the language good for quizzes, but that means the task even more interesting for us as a tooling vendors. So we started building tools for CMake as a language, creating things that could say autocomplete your targets or autocomplete your commands, or show you the documentation for the CMake commands you're using. Or for example, you can do the search for packages available in find packages command, and the tool can show you the options and you can autocomplete the package you need. This all makes and kind of reduces the pain of the developers who have to write the CMake with their hands. And I think that's the funny thing, that we have a debugger for CMake. I don't know any other project model which has a debugger, and I think that's fantastic that we get it. You can actually debug the CMake, and there are debugger in Visual Studio and in C-Line, and you can step through it, you can set the breakpoints, you can see the values of the variables. Just a proper debugger for the proper language. Come on, we have it. Yeah, I mean, it's great. It all started with some open source projects. It's not us or Visual Studio who started that for the first time. It was quite a nice open source project. They stopped at some point of time when we just continued their job. But I think that's just amazing. And it's now supported by the CMake, because the Visual Studio, the Microsoft people make sure that they contribute it back, which I think is amazing as well. So yeah, profiling, we talked about that, like CMake presets, which is a nice way of working with the CMake configuration. I think that's what we all needed, and the presets just make it easier to configure the CMake and then share it with the whole team. And the file API, which, and for that I want to say special kudos to the CMake team, because they made the job of us as a tool vendors much easier with that, because we simply send queries to this API and not just parsing some commands from the command line. But now you can also get help with the CMake with AI. And this is also amazing, because the AI is there to help you, and it knows about the CMake. They have documentation open, public in the internet. That means that AI knows about it. Be careful, because always check which AI backend you're using, because some backends were cut off before some CMake releases, so they might not know about some recent CMake additions, but generally they're quite good. And especially when you talk about working, for example, with the open source libraries, because they know both CMake and the open source libraries, they can help you. Say, if I ask how to link the OpenMP library to my project, and then the AI say yeah, just copy this code, and that will do the job for you. It works. And also, the thing I honestly, on my own, ask AI quite many times regarding the CMake is always when I'm trying to build a Qt project, and I remember that I need some CMake variable to pass the Qt prefix, but I don't remember which one and to which directory, and I always ask the AI, and it always gives me the answer. Talking about the pain points and the tools, another set of tools not directly related to C++, I'm not going to focus on that much, is about the development environments. I just think that it's important nowadays, after the pandemic, when we all were remote, to realize that we might not have access to the local machines or to the resources in the office. And we might need to have some remote development environments, which we could quickly connect from our not that performant home machine and do the job. And also there are security limitations because during the pandemic, some company says you either come into the office or you're not working because we can't provide the remote access, like just give the code to you locally at home. But the remote access sometimes is possible. And also the development environments, I think they're just amazing when you're onboarding the new people to the team. You don't need to, do you remember these long instructions of what you have to configure your first day at your work? And now it's just one button and it says like, get this development environment and start working with that. And then the new person just starts instantly and you are just focusing on explaining the project, the goals and the tasks that have to be done, but not the environment. I remember myself going through like pages of these configurations which fails at every step, and I'm going to my manager and asking like how to configure this and that. I know you just press the button. This is amazing stuff. You have to start using development environments if you don't. Back to C++, there were quite many pain points related directly to the language, which I colored in the language color. But as I said, there are some tools which can help you dealing with them. And that's about the safety, thread, memory, and type safety. The tools are learning to help you there. And these are the painkillers. So don't get me wrong, I would like to get the proper language support for that. And I would really appreciate some support for the lifetimes and many other stuff. But the tools can help me solve this problem right now. And I can avoid many issues with, say, dangling pointers right now with the tools. And the tool which is really powerful for that is the data flow analysis. The data flow analysis, that's a type of the static analysis which explores how the data flows through your code. That's not something typical to the compiler-based analysis, because the compiler usually doesn't do that. But the data flow analysis, it explores how the data flows through the code and then suggests some, brings you some assumptions based on this data, on these, how the data flows through the control graph. And the data flow analysis, DFA, could be run inside a function that's super quick. It could also be run on top of the translation unit. It's also quite quick, depending on the project for sure. But also there is a nice proof of concept done by Ericsson, I guess, for one of the LLVM meetup LLVM conference when they did the cross-TU data flow analysis. That's also possible. I don't know any cross-TU DFA implemented in production by now, but the translation unit-wide DFA is like a thing you can get in your tool. How it could help? Let's just look at a few examples. So lifetime safety. So you see I have this pointer, and my tool can tell me that the local variable can actually escape from this scope. And I can say, oh yeah, maybe I shouldn't do that. I should be careful with that. Another example, right, I guess, from the proposals regarding lifetimes, also could be captured by the tool, so the tool can say to you that the address of the local variable view may escape the function. This is already implemented, so if you take, for example, C-line, that will show it to you if you're on the DFA. So that's the actual example, so you get this. And it's implemented, the DFA in C-line is implemented on top of clangd. It's a proprietary code, we're not upstreaming that, but that just means that it's possible to do on top of the clangd for everyone who wants to do that. Bound safety, so you might notice that I kind of mixed my height and width, which you can already get, I'm mixing quite often. So I kind of swapped them by mistake, and the tool could notice that and say that index may have a value of 100, which is out of bounds. And that's because I'm doing the loops wrong. Use after free delete, you remember that from the pain points table, is also could be captured. So the typical dangling pointer could be detected by the tools this day, and it can show you that the pointer may point to a deallocated memory, which is great. And this The allocation might happen in another function. It's not necessarily in the same function. It could be somewhere in the translation unit or in the whole project. That's the cross-translation unit analysis. But as I said, I don't know the production tools doing that. But in terms of the translation unit, that's possible. So you can wrap your delete call with as many functions as you wish. The data flow analysis will figure that out. And the same for null dereferencing. So the tool can also get this and show you the potential error. So there are more tools with working with the like project models like Makefiles and Amasbuild, and there are for sure lots of tools for debug and C++ modernization, which is not the highest pain point in this table. It's always on the last spot there with this 9% at the bottom, but 9% is still a lot. And there are tools like clunktidy modernization checks, which help us with that. So generally, at least these blue points could be covered with tools. So what a relief. It actually feels much better now, right? So just a few not covered, but we'll get there. So for me, the magic goals for the tool is to build a safe environment for C++ developers where they can simply focus on their ideas and code how to implement their ideas, how to turn them into life, and not to focus in on all these things which could be on their way. Just to briefly relax, one silly story about the tools. Just because it happened recently, I was I was at ACCU a week ago, and I had a talk there. And I had my flight on Tuesday evening, and I had my talk on Saturday, and the talk was about surveying the community. What could possibly go wrong? And I call it as a subtitle, I call it that like it's a crash course on surveying the C++ community. And the crash actually happened. Tuesday morning, I got something similar to that. Not exactly like that, because that's the Linux kernel panic, but I got my Mac crashed completely with all my data. 6 hours before the flight. Our fantastic admin teams told me that because your Mac is not updated to the recent macOS version, we don't have time to run the full time machine. They managed to connect and actually get some data from the laptop. But what they did, they simply copied all the data and gave me this fantastic new laptop with all my data, even the browser caches, but no tools at all. So I got a completely fresh Mac with everything I had, but with 0 tools. And for the whole next 2 weeks, and I think that will continue for the next weeks, I was like, I will do this, oh, I don't have a tool. I will do this, oh, I don't have the tool. So first time in my life, I figure out that I'm in a situation when I have all the data I had, everything is available, but I can't do anything because I don't have the tools. That meant a lot to me. Let's briefly go to this point of thinking about the tools earlier. Actually, I have to say that I consider these as the most amazing group in the C++ committee. That's my personal take, because it's about the tooling. And the goals for these tools, as in one of the mails in the emailing list, the team at Daimler highlighted the major goals for this group in 2018 as there are several directions with which this tooling group could help. So they can analyze if the new language features are toolable. So they can simply read through the proposals and suggest. And they can actually provide some insights on the suggested designs. And if there are a couple of designs suggested, they can highlight which one is better in terms of the further toolability. And the toolability means that the feature will be quicker adopted, which is probably the goal for us, right? And also, this group could synchronize the efforts from all the tool vendors around these new features. And also, sometimes this group can tell the language committee that you don't need this tool. It could be easily solvable with a tool. You don't need this in the language. Just take the proper tool. And I'm happy to see that many new C++ language features are now starting with the Clang-based implementation. Sometimes you listen to the talk at the conference. Remember Herb? He's like, I love him for that a lot. So he's doing that all the time. Every time he speaks about his new idea, he already has the implementation in Clang, and it's already in Compiler Explorer. So you could try it right here just exactly the point when he's talking about that. I think that's amazing. I mean, when you can actually touch the feature and see how it goes, if it's actually toolable, that's a great opportunity. Because what you remember the stories about the C++ modelers? We were waiting for them for that long. We got them in C++20. Who is using modelers here? One brave guy. Thank you. You're really brave. Because, remember how that started? As soon as it was accepted to the language, the people started coming to us, to IDE vendors, asking, when we get the models in our IDE? And I was like, do you have it in your compiler, in your project model? How are you going to work with it? And they were like, oh, yeah, probably we have to wait. Yeah, we have to wait. We were waiting for quite a while because it all started like that. So Microsoft managed to deliver this VS generator stuff. It was not looking as real model. It was, I guess, some hacks around the CMake project model. It was a little bit better with some GCC and client compiler flags later, and only in CMake 3.25 they delivered it natively kind of into the language. And also in CMake 3.26, the support for models were finally added to the file API, which means that we can now extract it properly inside the IDE and work with the models from the IDE perspective. So modelers were a story of success for the whole community. But then we had the whole story of how we can nearly lose the feature because of the tools that were not ready. They were not prepared. They haven't got all their agreements by the time we accepted it to the language. Luckily, the excitement of the community is still there for the modelers. So we measure that. In our survey, we ask people which language features they are planning to use in the next year. And the modelers is still there on top. So that means that that's still good. So it's still with us. The people are not disappointed. And I hope that more thinking about the language features in advance will be in the language developers hat. And I'm super happy with, for example, Tima coming to us. He's no longer with JetBrains, but he still comes to us to ask about the contracts and about the stuff, how we use the asserts. And we were showing him these examples of how we are already using the asserts in data flow analysis. So we can easily add the contracts to that. The DFA, our static analyzer in our tool, will be able to capture all the stuff and to do all these pre and post conditions and all these contract asserts. We just need to add this, but it's not a rocket science. It's not a long task. And I was super happy with the Inbal when she was presenting the reflection talk at ACCU. So she just turned to me and asked, like, JetBrains, we need to come to you to ask about the reflection. And I actually said, yeah, because we sent this example to the mailing list and it was ignored when we were trying to explain that we see some issues with the tools because the ability to observe the compiler state by the user means that we can't rely on a lazy parsing anymore. Because say here, the A function, it's not inlined, non-context per function, and doesn't have the deduced return type. And as explained in this email by the link, that means that usually in the IDE, we skip parsing the body of this function. We don't do that for the optimization purposes. But that kind of affects the results we get later. So reflection is fantastic, but when we think about these things, we need to think also about how the tools work. They don't do the proper parsing. They need to kind of adjust to that. So yeah, this is the call that causes the problem. And actually, I'm happy to see this proposal, the Ecosystem International Standard, because it highlights the most important things of the collaboration between the language committee and the tooling vendors and the requests and the willingness to build this kind of thing and to see what are the basic definitions that we might need to talk at the same in the same language. So the specifications included in the standard. So what are the possible communication protocols between the build system and the package managers? What is the minimal set of the file name extensions understood and some other stuff? And what is this tool introspection? So what is the format and command options to provide implementation of this information? What is the output? And right now, quite many code analyzers indeed do the output in serif format because it's kind of some standard format you can work with. And we need everyone to follow that, probably, that's true. and some command line portabilities are also in the list of the goals. So I really think that this proposal is amazing because it sets the dialogue in the proper way. Finally, we are not at the stage when they deliver the language feature and then the tooling vendor sits there and saying like, okay, how we could implement that so that it actually works and doesn't break the performance. But we start this dialogue earlier, or at least we try to, which is very important. And the last part, just to end up with some funny examples, because AI is with us. We can't escape from it. It is already with us, and it can do good things for us, because similar to the IDE mindset, the IDE is so powerful when you work with the code because it knows your code base. It has the whole AST tree, and it can suggest you some features as you've seen before. And the AI also knows your project if you allow it to be sent to the language model or if it's running locally. And I've recorded several nice GIFs like that when I was, for example, here just coding some eigen calls with the AI, and all this code is just generated by the AI. So I'm just writing the comment explaining what I need to get. And because AI knows my project and it also knows the eigen library, so it just generates the code to me. Isn't it impressive? I think it is. It really like speeds up the way I do write the code. And it's AI currently, so it's really fantastic when we talk about the open source libraries, when it works with the OpenCV or eigen or Rust or Boost or standard library. And it also can improve the code. Say I ask the AI, can you just rewrite this piece of code for me? And so I asked, improve the code. And you see what the AI is actually doing. It generates the usage of the algorithms to me inside this code, which is also good. And the AI is, of course, fantastic in summarizing the code, like writing the documentation or version control commits. And maybe it can also help and summarize some proposals to me so that I read through them quicker. I haven't tried. Maybe I have to ask ChatGPT if it could summarize some proposals to me. And I already have seen the AI in action. I mean, I've seen many blog posts telling these fantastic examples, like the recent blog post from the Visual Studio team about the Copilot, how it was used in the time travel debugging team, with the actual examples from the time travel debugging team. Read through this post, it's just very insightful. It shows you how you can use the AI right here, right now, and how the companies like Microsoft are already using that in the real project, in the real team. And we also recorded with our developer advocates for the game development conference in San Francisco in March. We recorded a demo. It's not in C++, it's about the Unity game, but we coded a whole game in 15 minutes without writing a single line of code. We just typed the requests and these comments to the AI, and because it knows how to work with the Unity engine, it generates the whole game for us. It works. There is a demo by the link on YouTube. And we even see that the people are using the AI right now, so you can't just ignore it. They are, of course, the limitations, especially the security reasons are important to many people. So because you see that in many areas there people do have the security concerns, that's fine. But you can't just ignore it, because that's a powerful tool, which will be our tool tomorrow, maybe our main tool. So it could help. Just make sure that the ChatGPT version you're using is aware of the recent C++ standard you're going to use, because you need to check the cut date. And that's it. Thank you.